So when we solve real-world problems with scientific notation, a lot of the work is going to be about figuring out the problem first. So today's lesson is as much about solving real-world problems as it is about solving problems with scientific notation, okay? Because the skills of solving things with scientific notation, you guys do very well already. This says the Earth moves around the Sun at 6.7 times 10 to the 4th miles per hour. How many miles does the Earth travel after 2.4 times 10 to the 3rd hours? So, a lot of us, when we look at these problems and you see a rate over there like multiplications per, or miles per hour, you make an assumption about what the value should be multiplied or divided. And that's an assumption that you can't just make. All right, you have to make sure that you've gone through some work to prove it. So most of you are going to go through proving this by setting up a proportion. I will tell you, just as a courtesy to you, I would not solve this problem with a proportion. I use something else called dimensional analysis, which I want to introduce to you today. I'm not going to spend a lot of time on it, but I'm going to introduce it to you with this particular problem. So looking at this, I know that my answer needs to be some number of miles. So I start to set up my dimensional analysis by saying, hey, I know my answer is supposed to be in miles. I know that I have information here that tells me how many miles per hour, so I set up my multiplication with my miles on top. 6.7 times 10 to the 4th miles over 1 hour. So we can see this is very similar to proportion. However, what I do next is going to be very different. We can treat dimensions or units just like we can any other number. We can cross-cancel them. So what I know is that in order to get my units to cross-cancel, so the only thing I have left over is miles, I would need to know how many hours on top here, because that would allow my hours to cross-cancel. They tell me how many hours is 2.4 times 10 to the 3rd power. And because my units cancel out and leaves me with just my miles, that's how I know that I actually set this problem up correctly. That's how I know this should be a multiplication. And this is called the dimensional analysis, because I'm using the analysis of the units or the dimensions to determine whether I'm multiplying or dividing. Okay? So this is just another way to go through it. This is an extremely powerful tool when it comes to doing unit conversions. So when you need to convert things multiple times or have unit conversions inside of a problem, this makes this a whole lot easier. You could have used a proportion. You would have thought about it as 6.7 times 10 to the 4th miles over 1 hour is equal to, we have the hours are on the bottom, 2.4 times 10 to the 3rd hours, and you needed to find out X miles. It's the same thing. You can see that this is going to give me X. This would give me the multiplication of those two things, which we can see is the exact same thing that I have in my unit analysis. It's two different ways to approach this problem. So what we see is that this problem is really only asking us to multiply the two scientific notations together. (6.7) times 10 to the 4th times 2.4 times 10 to the 3rd. How do I go about this multiplication? Anadari? All right, so she's basically commuted it so she can associate these two things. We multiply that, we're going to get 16.08. And when we multiply the exponents, we end up adding the exponents, we get 10 to the 7th. Kip, yes or Kip, no. 16.08 times 10 to the 7th is in proper scientific notation. No. Okay, we should only have one number in the ones place. We shouldn't have anything in the tens place. So I need to fix this. I need to get the decimal to move to the left, which means I need a multiplication of 1/10. 16.08 times 1/10. And if I put that 1/10 in there, because it didn't borrow from somewhere, I need its balance. And we end up with 1.608 times 10 to the 8th power. You're welcome. Yes, I would get mad if you tried to tell me that you memorized the rule incorrectly again. Alright, so we're going to skip over this problem here. Mainly partially because we don't have time, partially because I believe the problem to be flawed. Alright, so looking at this, I have for one bottle of perfume, the perfume manufacturer needs 7,350 pounds of flower blossoms. If they made 10,000 bottles of perfume, how many pounds of flower blossoms would be required? Express your answer in scientific notation. Alright, so we could, again, set this up as a proportion. I'm not going to set this up as a proportion because I don't really like proportions very much. I prefer to use my dimensional analysis. I know that my answer needs to be how many pounds? So I know it's 7,350 pounds for one bottle. I know that I need my bottles to cancel out, so I need to find out how many bottles. Well, it tells me that there are 10,000 bottles. My units cancel out correctly. That's my unit analysis that proves that this is multiplication. So now that I see this is a multiplication, I just need to multiply these two numbers together. Now it tells me that my answer needs to be in scientific notation, which means realistically we have two choices here. We can do the multiplication first and then change it into scientific notation, or we can put the numbers into scientific notation and use scientific notation multiplication and end up with an answer in scientific notation. So, I'm going to give you the choice. Would you prefer to multiply these two numbers together first? Or would you prefer to change them into scientific notation first? Give me a 1 if you want to multiply first, a 2 if you want to scientific notation first. Most of you seem to be choosing to do scientific notation first. This is what I would do personally, because when you start doing this multiplication, 7,350 times 10,000, you have to do a really good job of keeping track of these multiplications of 0, and then you've got these placeholder zeros. And I tell you, the first time I did this problem this morning, I definitely messed up. I had something that was not in the right column. It's just too much to take care of. It's too much business to try and do in one multiplication. Which is why scientific notation is there. It makes this problem a lot easier. I check out this. I know that is really the same thing as 7.35 times 10 to the, I moved the decimal 3 times. And the 10,000 is the same thing as 1 times 10 to the 4th power. Now all I really need to do is shift this around. 7.35 times 1 times 10 to the 3rd times 10 to the 4th This multiplication gives me 7.35. This multiplication gives me 10 to the 3 plus 4, so we get times 10 to the 7th. It's already in proper scientific notation, so we're good to go. So I think this problem is a big example of why this skill is so incredibly useful when it comes to dealing with these really large numbers. Questions? All right, so Lake Superior has roughly 25 times the volume of Lake Erie. If the volume of Lake Superior is approximately 1.22 times 10 to the 4th cubic kilometers, what is the approximate volume of Lake Erie? So we have to go back and look at our given information here. Quick poll before we even start this problem. Show me a 1 if you think this problem is going to be a multiplication problem. Show me a 2 if you think it's going to be a division problem. This is an opinion question, so if you're not showing me anything, that means you are not involved in today's lesson at all. Multiplication or division, what do you think? 1 or 2? So we've got a mixture around the room. Once again, we have to find a way to prove the way that this is going to go. So the way that I do this, and honestly, when I look at problems like this, the only way that I actually figure out whether it's multiplication or division is to create an equation. This tells me Lake Superior is 25 times Lake Erie. Superior is equal to 25 times Erie. It's an equation. I'm going to plug in the information I'm given. I'm given the information for Lake Superior. 1.22 times 10 to the 4th is equal to 25 times Erie. How do I solve this equation? Do I need to multiply something to both sides or quote unquote divide something on both sides? Sophia, do I need to multiply something to both sides of this equation or divide something to both sides of the equation? So if I multiply 25 to both sides of the equation, is that going to get my E alone? Sophia, is that going to get my E alone? No, because we end up with 25 times 25. That doesn't help out. So what do I need to multiply by? Or what do I need to divide by? Multiply or divide it? So divide it, or really we can think about it as the multiplication of the reciprocal. Either way is really fine. And that tells us that after our cross cancel, Erie is equal to 1.22 times 10 to the 4th over 25, or basically we're dividing. Now I'm going to want my answer to be in scientific notation, which means once again I have a choice. I can take the 25 and I can put it into scientific notation and then use scientific notation on this problem. Or I can go ahead and do the division. I can go ahead and do the division and then put it into scientific notation. Show me a 1 or a 2. 1 is I would like to put it into scientific notation before I do the division. 2 is I'd prefer to do some division and then figure out the scientific notation afterwards. Mixed opinions here. So the reality of it is that we end up with this really being 10 to the 1st power. If we're going to change this to 2.5. And so for me, when I look at that, I'm like, well, that's really not going to be incredibly useful. So for me, I'm actually just going to immediately take this and divide it. I've got 1.22 divided by 25. And whatever I get to that, it's going to be with this left over times 10 to the fourth. Decimals here, 25 goes into 122 4 times. Goes in 8 times. Goes in 8 times. So I get 0.0488 times 10 to the fourth power. Kip yes or Kip no, is this in proper scientific notation? No, this number is not between 1 and 10, so we need to move it. Which way do I need to move the decimal? To the right. What do I need to move it to the right? A multiplication of 10. Do I have any multiplications of 10 already? I have 4 of them sitting over here. Let's borrow 2 of them away. 1, 2 times. And if I borrowed 2 of them away to do that, 4.88 times 10 to the second power. So Lolly, 3 times 10 to the 8th meters per second. If the sun is 1.5 times 10 to the 11th meters from the sun, how many seconds does it take light to reach the earth? So again, we have to determine a way to figure out whether this is a multiplication or a division. Please show me with your fingers. A 1 if you believe this is going to be a multiplication of these two numbers. A 2 if you think this is going to be a division of these two numbers. So this is exactly why we actually have to spend some time using a proportion or using dimensional analysis to figure it out. Every time you guys see something that says something like meters per second, you make an assumption that it's multiplication. In this case, it actually is not going to be. Let's set up the proportion to prove it. I have 3 times 10 to the 8th meters per 1 second. I am being told that we have 1.5 times 10 to the 11th meters. Remember, to set up for proportions, you have to have same units on top, same units on bottom. I need this to be finding out x seconds. When I cross multiply, that gives me 3 times 10 to the 8th x is equal to 1.5 times 10 to the 11th. How do I solve for x? Anadari? So we solve the equation by dividing both sides by 3 times 10 to the 8th. That gets our cross-canceling going on there. Here, we see this is just a scientific notation division, and we'll break it apart. 1.5 divided by 3 gives me 0.5. 10 to the 11th divided by 10 to the 8th gives me 10 to the positive third, because we have 10 to the 11 minus 8. Kip yes or Kip no, is this in proper scientific notation? No, it is not. So we have to take 0.5 times 10 to the third. I need to move the decimal once to the right. Is that a multiplication of 10 or a multiplication of 1/10? 10. Do I have any 10s already?
Yes.
All right. I'm going to take one of them away. That's going to leave me with 10 to the second power. This gives me 5 times 10 to the second power, which is actually 500, which tells you that it is in the range of 7 minutes.
7 minutes? Very slow.
to take the light to get from the sun to the earth. So the light that you are seeing from the sun, that happened 7 minutes ago.
Wait, that's. Maybe.
That light was created 7 minutes ago. Sorry.
Maybe.
That's old light. Not as old as the light if it were getting to Pluto, though. Okay, so the size of the Indian Ocean is 2.7 times 10 to the 7th miles, square miles. The Arctic Ocean is 1/5 the size of the Indian Ocean. How big is the Arctic Ocean? So I need to determine what this actually is set up as. So it tells me the Arctic Ocean is 1/5 the size of the Indian Ocean. Arctic is 1/5 of the Indian Ocean. This is the equation. I'm going to plug in the information that I have, which is the Indian Ocean. 1/5 times 2.7 times 10 to the 7th power. So really this is just like dividing by 5. So I'm going to multiply the 1/5 times the 2.7. And if you do that, I'm going to go ahead and tell you that's 0.64 times 10 to the 7th. Kip, yes or Kip, no? This isn't proper scientific notation. So do I need a multiplication of 10 or a multiplication of 1/10 to get where I need to go? Need a multiplication of 10. Do I have multiplications of 10 that I can use? Yes. So I'm going to break one off.
10 to the 10th power, then it becomes 6.4 times 10 to the 6th power. Yes, and you took it away.
6.4 times 10 to the 6th.